Hello guys, today we're going to be dealing with Trigonometry chapter 22, exercise 22E, question number 10. So this question deals with a goalpost being hit by lightning and being snapped in two. So the top of the post is now resting 15 meters from its base at an angle of 25 degrees. Find the height of the goalpost before it snapped. So firstly, we will jot down the important information from here. So there was a goal post which was snapped in two, and then the top of the post is now resting 15 meters from its base at an angle of 25 degrees. We have to find the height of the goal post before it snapped. So you can look at the figure and then just solve the question, but I would recommend you to try to make the figure by yourself so that it helps you in other questions where you have to make the figure by yourself, and it gives you a bit of practice and a more deeper understanding on how to solve this question. So let's make this diagram by ourselves by looking at the question. So there was a goal post. Let's name the top A and the base B, and then it was snapped in two after a lightning hit. So this is before the lightning. So this figure is before the lightning. After the lightning, this was A, this was B. So the lightning hit probably at this point, and it snapped at C. At point C, it snapped. And when it snaps, it falls down. So this A, this is B, and this is the point where it snapped. And so this A is lying on the ground because it snapped. Now this A, that is the top of the post, is 15 meters from its base. So A is 15 meters away from B, that is AB is equal to 15 meters. Once we know that, we also know that there's an angle, it is at the angle of 25 degrees. So this angle is 25 degrees, and there we have it. We have the diagram that we needed to draw. And this is of course 90 degree because the pole before was standing upright. Now we have to find the height of the goalpost before it snapped. So remember how the goalpost was like this when it snapped. So we have to calculate AB, but because it had a snap at C, we have to do AC plus CB. So when it snapped, it basically landed like this. And if this is C, this is B, this is A, we have to do AC plus CB, and that would be our answer. So let's get into it. So for solving, we have to calculate this and this. To calculate AB, you can use trigonometry and you can use tan because this is adjacent. This is the angle, this is adjacent, and this is opposite. So if I write we're going to be using tan over here. But if we have to calculate AC, we can use three methods. Either you can use Pythagoras theorem because you already know AB, so you can do AB square plus 15 square, whatever is the answer, you square root the whole of the answer and then you get AC. Or you can calculate AC by using BC by using cos, but because this is a hypotenuse and this is adjacent, so CAH. Or you can use a sine, and you can use AB over here, and you can use you can calculate hypotenuse by using the opposite. So the best method is basically to use this value because this is given and you can't possibly get it wrong, but you might get AB wrong and then you'll subsequently get AC wrong if you use the other two methods. So how we'll start is that first we'll say that ABC is a right angle, thus we're going to use trigonometry. So we'll start with, in triangle ABC, angle ABC is a right angle, thus to kind of justify the fact that we're going to use trigonometry or Pythagoras theorem or whatsoever. Now we're going to write down the things that we already know, such as we know this angle is 25 and we know that this length is 15 meters. So we're going to write AB ACB, angle ACB is 25 degrees, and that's given, and length BC is 15 meters. That's also given. And now we're gonna look at the sides. So we're probably gonna first solve AB because that seems the most logical one. I mean you can solve any one of them before. It doesn't really matter. So first we'll write SOHCAHTOA because you don't want to mess up anything. So you don't want to mess up sine and cos and then calculate the whole answer wrong just because of the fact that you used cos instead of sine. So here we have to calculate AB. So we will be using it. This is adjacent, so this is opposite, and this is the angle. So we're going to be using tan because there's opposite adjacent. So we will say tan 25 degrees is equal to opposite, that is AB, upon adjacent, that is CB. Now we're going to plug in the value of CB, and we're going to say tan 25 degrees is equal to AB upon 15 meters. And then we'll calculate AB, and we'll get AB is equal to tan 25 degrees into 15. Well, how did we get here? So from here you can see that AB is equal to AB is equal to tan 25 degrees into 15, because 15 goes over here and it becomes multiplication because it's divided over here. And then we calculate AB from here, which will get 6.99 meters. It's not accurate, but it's not the exact value, but it's approximate. Then we're gonna calculate AC. So I told we're gonna calculate AC by using BC because that is the most the most logical way to do it, and the way that would ensure that you'll get the answer right. Okay, so we're gonna start with looking at if we have to calculate this line right over here, and this is the angle, this is the hypotenuse, and we know the adjacent, so we're going to use A and H. We're going to use cos. We're going to say cos 25 degree is equal to adjacent upon hypotenuse. Adjacent is CB, hypotenuse is AC, so CB upon AC. That is equal to CB is 15, AC we don't know, so we plug in the value of CB, and then we again kind of like pull this down. We replace AC and cos 25 degrees to get AC is equal to 15 upon cos 25 degrees, and then we calculate it on a calculator to get the value of AC as 16.55 meters. And then we move on and say that we have to find the height of the goalpost before it's snapped. So the height of the goalpost before it's snapped is equal to height of the whole pole, that is AB plus AC. And then we plug in the values of AB and AC, and then we get 6.99, that is AB plus AC, that is 16.55. Why did I write 25? Well, it's not 25, it's 55. I'll change right now. And then we plus both of them, and then we get 23.54, and that will give us the value as answer as 23.5 approximate, because in examination you are supposed to give the answer till one digit rather than 2 decimal places. So you'll just say 23.5 because 4 is less than 5. So this will be approximately equal to this. And that's it. So thank you.